Hello and welcome to Process Control Made Easy. This is our part number 2, the linear 7th axis for robots. We'll be doing a software overview and then dive into the Java code. So, what does our system look like? Well, we have a master computer running Windows 10 and Java, that's a PC, a universal robot that's running Polyscope, and we have our Galil motion controller using Galil Design Kit. And outside of that is our safety system. That's the environment we're working in. Now what we need to do is turn over and really take a little deeper dive into the programs. And what we have is the master controller. The master controller runs the robot program selection, the robot program start stop, the motion control program, and the motion direction. Java program is the GUIs and the base code. So what are we actually going to do? Well, here's the first Java GUI. And what we're going to build is we're going to build a 7th axis system that's really designed for a machine shop with up to 5 workstations. It's totally integrated control of the motion axis and also the robot. And we'll build the application in steps from start to finish. To do this project you're on a PC, you need to have installed your Java SDK. You also need Java Runtime, and you can get those both from Oracle. You need an integrated development environment. We're using NetBeans, but you certainly can use Eclipse, IntelliJ, or whatever you'd like. And you'll finally need a text editor such as Windows Notepad or Adobe Brackets. And that's really what you need, so get those installed, and then we will just go ahead and jump right into the programming. By now you've got your IDE installed, and you've hopefully written the 3 text files, which are shown here, which is the MIP.txt file, and this is for the motion controller IP address, although it doesn't look like an IP address because we're going to convert that in the Java program. So that would be the first quadrant 192, a comma, second quadrant 123, a comma, 456 is in the third quadrant, a comma, and 789. Do the same for the robot IP, which we are naming RIP, and that's 192. It's the same, just copy it and rename it to RIP.txt. And then finally you have the motion ADS.txt file, and for that you're going to have 3 values, 50, 50, 50. So those are your text files, and you've saved them into your project directory on your C drive or wherever you're going to save them. So we're going to close these, and we're going to open our Java program. Now, I have written everything, so we're going to deal with the finished product, but we're going to do it in sections. And as a note, I'm not going to go through all of the code because that would take a long time to do that. But if you want the baseline code, just go ahead and send me an email, and I will send you the code for the area that we covered. Just let me know which section this would be. That's the best way to do it. And I'll send it to you in a text file. That way it's smaller, it's compressed, and you can just copy and paste it into your IDE. So with that, we start out with the C7MS V3, which is the package, and the class is C7MSV3, and this is our main method. It's going to do just one thing. It's going to call the home class and the home method. And the home class and home method is a GUI, so let's pop over and take a look at that. And here is the home method and home GUI. Now, this is all done in Java Swing, because it's a lot simpler than making this an FXML project, because there's a lot more steps involved in that, although many folks would argue it's going to make And it does make a cleaner GUI, a better looking GUI, but this is a lot easier, and this is all about functionality. So basically we just have a number of buttons. We have the configuration button, the upload program, home, C7, calibrate, output results, monitor, and then we have exit, we have stop, run, and run. And then we have a number of radio buttons here for machine status. We have 5 workstations. So you click those to indicate that it's online, or unclicked is offline. And then the update line status. It's kind of important for, let's say, configuration. If we go to configuration, which is the only thing we're going to deal with today, in configuration, in order to, now that you have the button here, and you go down into the code section in your palette, we have named this as config_btn. Then we go back up to the configuration button, and we're going to go ahead and right click on this, and you'll see that it brings up a sub menu. You go to events, come on down here to mouse, and mouse click, config button, mouse clicked. So if we click that, it'll take us right to the method for configuration. So we'll go ahead and do that. And as we look at that void, now it's important when you look at the code, if you decide that you want that code, all of the lines from 38 through 240, these lines here, are system generated once you build the GUI. So I'll go ahead and expand that. It's all the gray area here. We're not going to go through that because, again, it is system generated. So I will hide that again, and we'll come down here to the void, which is config button. Now we're going to call the ipconfig class and the ipconfig method. So let's go over to ipconfig, and again you will see that this is a GUI. Now this GUI is a little bit different. It has 2 buttons, exit and save, and then it has 8 spinner boxes for the IP addresses and 3 spinner boxes for the motion controller dynamic settings. And now, a word about this: I've elected to put the validation inside of the spinner model for these. So I'll just click on one to show you, and then you can kind of take it from there. And again, this is all in the code. So if you want that code, please, give me an email. So anyway, let's click on robot, and these are the quadratures, if you will. So I've broken them up in order to make this a little bit easier to validate. So let's take a look at the code, and the very first thing is, here is the variable name. So this one is R1 V, lowercase v, uppercase G. All right, and our properties is where we're going to set the spinner model. And in the spinner model, let's just go ahead and click on the spinner model itself. It comes up here, and we're going to see that the model type is a number. If you click this, you'll go. You can select default, date, list, number. So this is a number. It's an integer, and again, if you click that, you'll get a number of different options. You can go byte, double, float, integer, long, short. We're obviously an integer here. The initial value we're going to set as 1. The minimum is 1. The maximum is 999. And the step size is 1. So that's where our validation takes place. Now, in terms of the code itself, essentially what's going to happen here is when we initiate the GUI, it's going to pull in these values and parse. It's going to break the strings on the commas, and then parse those into integers and drop them into each one of these boxes. Okay, it'll do that for the robot, it will do that for the controller, for the acceleration, deceleration, and the cruise speed. Again, I'm not going to show you, I'm not going to go through the code because the code is extremely lengthy, and it certainly is worth your time. You can just copy and paste it and drop it in, and then when you're done with that, you should be able to run this. You may want to put in a few system out print lines in order to track this, but you should be able to retrieve your files, the text files, put in new values, whatever your robot IP value is, whatever your controller IP value is, and then your acceleration, deceleration, and cruise speed. And then hit save, and it will save all of your files. Close the program, open it again, come to the config screen, and you will see your new values pop in here. So pretty much, let me just scroll through the code quickly, and you'll see what I mean about it being a little bit long. We'll go over to the source code for the IP config, and we've got our imports section up here. I'm assuming that you have some Java knowledge, so you know all about the imports. And then we've got our public integer variables here. That's for the robot IP, the motion controller IP, and the acceleration, deceleration, and speed. Then we go through the various methods. We set the IP address, which is basically just go out and get the text value of each one of our spinners, pull it back, and put it into a public variable. And then in terms of our save, we go through a number of try catches, and we start out with our strings. So we're picking up our strings, we're reading those text files, and preparing it for the for you to change, edit, save, whatever. Then in our get controller IP address, basically it's the same. It's more or less the same piece. And again, as you drop the code in, you go through it, you'll see the flow of the code. But we go all the way down here where we start to write the information from the spinner boxes to the text files. And you can see that we've got roughly about 500 lines of code. So a little longer than a video should be. But again, if you want to see this, be happy to send it to you. Send me an email at jerry@reefworks1.com, and I'd be glad to send this code to you. All right, we will see you in our next video.